Hello everyone, my name is Namuga Matha and my AI project is seed sorting. So my presentation is as follows this evening. I have the introduction, the problem statement, the data set, the factors I considered while choosing a data set, the features for this data set, the Bayesian theorem, the naive Bayes theorem, the Bayesian networks, the difference between the Bayesian theorem and the naive Bayes, the difference between the naive Bayes and the Bayesian networks, and a few references. So we all know that coffee is one of those exports we deal in Uganda, and it contributes approximately 6.76% to our GDP. And we have around 49 million people growing this coffee all around Uganda, Masaka, Lira, Gulu, Mbale, Mukono, in different areas. And coffee usually dealing is Robusta and Arabica coffee. So the problem I identified is that, yes, we do export coffee, but to what quality? And according to research, we import roasted coffee. Why do we have to import roasted coffee when we can actually roast it and package it? We can sort it according to different levels of roast, and we can export it or even consume. This is going to increase in the income as a country, as an individual, as these farmers, and also that reduce the expenditure we make on this importation of roasted coffee. We can roast the coffee and then sort it to the different levels and package it according to those levels to suit the different demands of the different people. This gives us an ability to be able to compete fairly on the world market. The data set I've chosen is the coffee bean data set. This data set contains images of different coffee beans roasted to different levels. So this model is going to be able to identify and distinguish between the different coffee beans and sort them according the dark that have been really roasted, the brown that are intermediate, the green that have not been roasted at all. So this model is going to be trained to identify and distinguish between these different coffee. So the factors I considered when choosing this this data set is that we have images. The image resolution is good. Given that the seeds are small, this data set has good quality of these images, in that the model can easily identify the different types of beans. And we also have the sizes of these images is good. You can clearly tell this is brown, this is blue, this is orange. And we also have this data set is comprised of 4,800 photos. These photos are good enough for the model to learn and be able to identify the different, and in each category there are 1,200 photos. This is quite enough for the model to learn and differentiate between the different coffee beans. So we have the features for the data set. This data set has images, and these images have a text label. And then this data set, there are two different types of images. The images that are meant to train the model and those that are meant to test the model. So those that will train the model, and thereafter we'll have the images that will test if this model is actually doing what it's supposed to do. Can it differentiate? If I give it brown, will it know this is roasted or this is not? And then we have the class index that identifies the group in which a different coffee falls. We have index 0 that will have roasted, index 1, intermediate, index 2, those that are not roasted. And also this data set has a file path for the image. So that's why I opted for this data set. We have the Bayesian theorem. So the Bayesian theorem is basically a method to determine conditional probabilities. You may ask, what is a condition probability? Condition probability is the ability of, and it's the probability of an event occurring given that another event has already occurred. So what is the probability that the machine will predict the outcome of an event given its knowledge on another event occurring? So that's Bayesian theorem. This is its formula. We have the probability of A given B is equal to the probability of B given A times the probability of A divided by the probability of B. So what is A? A is a hypothesis, what we do not know. B is the given data. Then probability of A, that's a probability of the hypothesis before we observe the data. And then the probability B is a probability of the given data. Then probability of A given B, we are trying to find the probability of the hypothesis given that the data we have is true. And then the probability of B given A is a probability of the given data provided the hypothesis is true. So that's it about Bayesian theorem. Can the machine predict the outcome of an event basing on the prior knowledge it has on another event? So that is the Bayesian theorem. And then we have the naive Bayes theorem. This is a probabilistic machine learning algorithm used in a wide variety of classification tasks. So this naive Bayes is actually got from the Bayes theorem, and it assumes that all the features are independent. The length will be independent of the radius will be independent of the color, and in naive Bayes, it's straightforward. Okay, according to research, it's not realistic because at some point things are supposed to relate, but it's very simplistic and straightforward. So the main difference between the naive Bayes and the Bayesian theory is that this one will look at something independent. The features are independent. If I'm to look at the bean seed, its length should be independent of its color. The color should be independent of the radius. The radius should be independent of the convex corner, all those things. So every characteristic should, so you can predict what is the, you can use this information to classify these different types of beans. So we will classify those that are over roasted, those that are mediumly roasted, and the ones that are not roasted. So you use these characteristics, these independent features, you find the probabilities, and then you can use those probabilities to classify the different coffee beans. And then we have the Bayesian network. The Bayesian network is also known as a belief network. So it consists of the directed cyclic graphs and also a table of conditional probabilities to find out the probability of an event happening. So we know we have that in the Bayesian networks, you have the nodes, you have the edges, where the edges connect the nodes. So taking a look at this directed cyclic graph, we have the rain, we have the book, we have dog barks, and then we have cat hides. So in a directed cyclic graph, you know the word says directed. So as you see, there are these arrows. So this is showing us if it rains, the dog will bark. And if the dog barks, the cat will hide. So there is that direction that it follows. Yes. So the dog will bark given that it has rained. Then the cat will hide given that the dog has barked. In such situations, the hypothesis should have two probabilities. Yes. So this is a directed, this rain, this is a node. This rain, dog, and then the probabilities are given from we take probabilities from the parent node. That's why in a conditional probability table, we have rain and a dog barking. We don't have the cat here because the cat is not it's not directly from the rain. So if we have, what is the probability of the rain raining and the dog barking? Then a probability of it not raining and the dog barking, it raining and the dog doesn't bark, then it doesn't rain and then the dog doesn't bark. So this is our conditional probability table. Well, this is our directed cyclic graph. So these two make up our Bayesian networks. Yes. So what's the difference between the Bayesian theorem and the naive Bayes theorem? We have seen that the naive Bayes theorem deals with independent features. As I had earlier explained, the features are independent of each other. A change in one will not affect the other. If the length changes, it will not affect the color of the pin. If the radius changes, it will not affect the color. So if the color changes, it will not affect the radius. That's naive Bayes. There is independence. And then in Bayesian theorem, we have, remember, we are predicting the outcome of an event given the information we have of another. So there is that bit of relation between the two things. So that's the main difference between the Bayesian theorem and the naive Bayes theorem. And then we have the difference between the Bayesian networks and the naive Bayes networks. As we already know, in what naive Bayes, there is independent, the features are independent. But as we saw in the Bayesian networks, there is a difference, there is that relationship between the different features. For the dog to bark, it should have rain. So for us to have a color, it should be this length. There is that relationship between networks, and naive Bayes is a subset of the Bayesian networks. How it's that subset where the features should be independent of each other. And given this independence, it's very simple and can easily be worked on, because we know if a seed is long, it will be long and it will not affect its color. But the Bayesian network has that relationship. So given that if a relationship is the relationship between the radius and like the length, if we know if it increases in length, the radius has to change. So there is that continuity. So the workload it's a lot of workload. So these are a few references: the Bayesian network, the naive Bayes, the coffee bean data set that I'm going to use throughout this entire process, and the Geeks for Geeks. Thank you so much. Have a lovely evening.